of this chapter is called Rewriting Equations and Formulas. Now, I would kind of dare to say that the formula one is probably more important because we see a lot of formulas in geometry and when you get to science class. So this is a really important skill. Now, oftentimes you'll hear something called a literal equation. More than anything, you see this in the directions. So it's not really something you're going to be tested on. It's not something you have to memorize or anything like that. But if you see the word literal equation, I don't want it to throw you off. A literal equation is basically an equation that's mainly made up of variables. And so if we were together, I would ask you for an equation that you know of that mainly has letters or variables in it. And many of you would probably throw out Pythagorean's theorem because that's a pretty popular one. A squared plus b squared is equal to c squared. That is going to find you the missing side of a right triangle. And notice, yes, it has numbers, but it mainly has variables. Another one that many of you might have thrown out would be like the area formula for a triangle. So area of a triangle is 1/2 base times height. Now, yes, we do have a number in there, but look at, we also have 3 letters. So what you're going to see in today's lesson, and if you look on this next page, I believe there's just 11 examples, is they start off with what they call a literal equation for y. Essentially, what they're trying to get you to do is put this into slope-intercept form. That's really what they're trying to get you to practice here, because why else do we need it in y equals? And if we use Desmos, a lot of Desmos, or even if we look at our graphing calculator, notice when we try to graph, our graphing calculator only understands y equals. So if you were trying to graph number 5 from your homework assignment, you have to get this into y in order to type it in the calculator. Now, when you look down below here, notice they do tell you what the formula goes to, although it's not really important. The only thing you care about is what is the formula and what letter do they want you to isolate. So notice how it says solve the formula for the indicated variable. You just need to get this letter alone. So that is the entire lesson. So let's go through a couple, and again, then you can pause it and kind of go from there. So on number 1, again, you're trying to get the y alone. So all you have to do is move the other items away. So if we have a minus 2x, we simply add 2x. We just do the opposite. So we have 15 plus 2x, and then we're done. That is our answer. There's nothing else you have to do there, okay? Now, when you look at number 2, essentially we're going to do the same thing. We just have to be careful because notice where the subtraction is. So the 3 is positive. So what we're going to do is we're going to subtract the 3x. And the subtraction here belongs with the y. So we have to leave that alone. Now, in order to get y completely alone, we do have to get rid of this negative sign. And because it's being multiplied, we are dividing. So we're actually dividing by a -1. And that's going to make these cancel, and then we get y equals a negative divided by a negative is a positive. A negative divided by a negative is a positive. And then now we're done. So it's really just trying to get them into slope-intercept form. You just have to kind of work one thing at a time. So why don't you pause the video, and again, if you want to pause it and try just number 3, or you can try 3, 4, and 5. But why don't you kind of only do those and then check your work with the video to make sure you're doing it correctly before you move on. Okay, hopefully you paused it. In number 3, notice I'm trying to get that y alone. So the first thing I'm going to do is I'm going to move the 5. Like that. Then I'm going to divide by 3. Now this one gets a little messy. 12 is divisible by 3, but 5 is not. So I don't care, and I don't think many teachers here, so if you have Clausen or Busker or whoever you have, I don't think anyone cares if you leave it like this. Or if you want to split it apart and go 12 divided by 3, and then this one obviously would be a decimal, so we probably would just recommend that you leave it as a fraction, because if you were to graph this, if you were to graph it, you would start at 4, and then you would go down 5 over 3, down 5 over 3. So graphing in fractions is easier than if we were to change this to a decimal. So it really doesn't matter which one you leave. I sort of like this one a little bit better, just in case we have to graph, but it's ultimately up to you. Okay, number 4, I'm still solving for y because that's what they told me to do in the directions. Notice how the literal equation, I really didn't care what this was, basically solve the equation for y, okay? So I'm going to move the 8 first. Move the 8. I'm going to divide by the coefficient that's in front of my variable. That's the one I want to get rid of. Now, in this particular case, both of these are divisible by 5, so it really makes sense to go ahead and divide it out. So 5 divided by 5 would just be 1. Negative 10 divided by 5 would be 2. And then that would be my answer. Okay? So not real hard, just got to kind of watch your watch the little steps and the little mistakes that can be made, but not too bad. Oops, sorry, I don't know why I highlighted that. I meant to highlight the Y, so I apologize. Can't erase that, so I meant to highlight the Y there. That's what we're trying to isolate. So we're going to move the 7. Now notice the 7 is positive, so we're going to start by subtracting the 7. So it's going to be a negative 6 plus 3x. Do you see how I kept the subtraction sign with the 4? Now I'm going to divide by negative 4. Now again, what do you want to do here? You've got negative 6 plus 3x divided by negative 4. Both of these are fractions. So I think a lot of people would leave it. Some people might go ahead and divide out the 6 and the 4. So 6 divided by 4. So you have 1.5 and then minus 3/4 x. So again, if you were to graph it, that intercept would not be very nice. But if you were to graph this, we could start at our intercept of 1.5 and then go down 3 over 4, down 3 over 4. I mean, the intercept would not be the greatest thing to count from, but we could do it. So it might make more sense to change that one to a decimal, okay? So hopefully you understand how to do those ones. And now below the line here on 6 through 11, again, they're telling me what this formula goes to, but ultimately I don't really care what that is. What I need to do is I need to get this letter completely alone. That is the letter I want all by itself. So I need to move the N and the T to the other side. Now, the question I would ask you if we were in class is, what operation is going on here? Is this N plus R? Is this N minus, times, or divide? And hopefully you would say that these are all multiplication. So the opposite of multiplication is division. So I'm going to divide both sides. And because these are both multiplication, I can divide at the same time. So I can divide the N and the T at the exact same time. So I have PV divided by NT. So the N and the T canceled, and the only thing I have left is R. Now the worst part about this answer is there's no way to check. There's no way to check to know if you did it right besides asking the teacher, okay? So that is the correct answer. Number 7. Number 7, you're solving for H. Again, if you have a hard time seeing the printed on this on the projection here, please feel free to bring up the blank copy of notes that we have loaded into your Google Classroom site. Okay, I can divide this B off if you want. I'm happy to do that. However, I would rather get rid of this. Now, a common thing I hear a lot of people say, so if this is your formula, and I'm trying to get the H alone, people will tell me to divide off the half. They'll say, go like this, like we just did on the last problem. Here's the problem. So cancels, cancels, that looks good right here. This is a problem. You cannot have two fraction bars in the same answer. This is called a compound fraction. And this is a big no-no, okay? So we don't want to really divide by the half. What we really want to do is use a term that I know you've heard before. It's called the reciprocal. We want to multiply both sides by the reciprocal. Now I'm doing this one step at a time again so you can kind of follow along. I could combine steps, but I don't want to lose anybody here. So a half times 2 is going to cancel out. And so notice I still have the BH. And then I just do 2 times A. And remember, my goal, is to get B alone. So I'm trying to get the B alone, not the H, okay, the B, which I apologize over here. I kept it as H, but it doesn't matter. I could easily switch this to divide by H. That's not that big of a deal, so I apologize. Okay, so if I'm trying to get the B alone, I just now divide off the H. So see how these cancel. So I have B is equal to 2A over H. And that's my answer. So if you want to try, go ahead and pause it, but I really would tell you, because these ones are a little trickier, watch each video before you move on to the next one because they all kind of have little twists and turns to them. So don't go too far and then realize you've got to go back and make a whole bunch of corrections. So if you'd like to pause it here, go ahead and do so. Okay, I highlighted the correct letter this time. I'm solving it for R. I'm going to deal with this 1/3 first because I know many of you don't like fractions. So I'm going to use the reciprocal. So I'm going to times it by 3 over 1. So I'm going to have 3v, and so this is going to cancel, and so I'm left with pi r squared h. Now if I'm trying to get the r alone, I'm going to move the other 2 items that I don't want. So because they're the same operation, I can move them together. So I have 3v equals pi h, and now the pi and the h canceled, and I have r squared. Now, I know it's been a while, so kind of work out some cobwebs here. How do we get rid of a square? Just like how do we get rid of a multiplication? We have to do the opposite. So the opposite of square is square root. So for example, if I tell you 3 squared, that's 3 times 3, that's 9, correct? Well, let's go backwards. If you take the square root of 9, you get 3, which is 3 times 3. That's how you get to 9, okay? So it's just kind of working forward and back. So if I take the square root is going to cancel the square. But I have to take the square root on that side as well. Now, the problem here is you can't take the square root of variables. So your answer is kind of a huge mess. I mean, look at that thing. It's really not very pretty. It was almost better at the beginning. But this would be your answer, okay? All right. Now, number 9, I'm going to caution you to even do this one on your own at all. Here is the most common mistake that I have seen over my years of teaching. Are you ready? You're going to multiply. Okay, hold on. Do you see how it says to solve for r? So you're trying to get r alone, correct? Okay. You're going to multiply by v. And you're going to tell me the answer is IV, because we typically write them in alphabetical order, is equal to R. And that is incorrect. What you have done right here, this is fine. But what you've done here is you've now created v squared over r. This is in the numerator. So you always want to multiply by the denominator. So watch what I'm going to do on number 9. I'm going to multiply by r. Now that's very uncommon. Typically, the letter that I highlight is the letter that I do not move. But in this particular case, because it's in the denominator, I'm multiplying by it. So now my r's are going to cancel and I'm left with v. Now on this side, I have IR. Now remember, the order doesn't technically matter due to the commutative property. Now because I'm trying to get the R alone, I'm going to divide off the I. So I have R equals V divided by I. And that is my answer. Okay? That's really tricky because it's in the denominator. If it's in the numerator, then it's different. So you just have to be careful on that, okay? All right, 10 and 11, if you want to kind of pause it, I wouldn't say there's any huge things to watch out for. Just make sure you can do them before you get to your homework and you kind of get stuck and then there's no explanation. So if you want to pause it and try both of them, that's totally up to you. Okay, hopefully you pause the video. We're going to go ahead and solve this one for M. And we're going to move the B first. So we have y minus b is equal to mx. And again, if I'm trying to get the m alone, I'm going to divide off what I don't want. Now in this case, I'm probably just going to leave it as a fraction because if I try to divide these, I would get y over x minus b over x. I mean, is that really any better? So I would probably just leave it like this, but again, it's totally up to you. That's a personal preference, okay? All right, good old Pythagorean here. We've got b squared. So the first thing we're going to do is we're going to move the a squared. So we've got b squared is equal to c squared minus a squared. And then remember, the only way to get rid of this is to do its opposite. So we're going to take the square root. So the square root is going to cancel the square, and so we're left with b. Now, it's very common to try to take and cancel these. But because of the subtraction sign, you can't do that. So you just have to leave it c squared minus a squared like that. And then that would be your answer. Okay? And that concludes lesson 1-5 along with chapter 1.